So we have now shown that the matrix that describes this linear transformation is going to have a positive determinant, and what that means is that the linear transformation is going to be orientation preserving. Now that proves that this vector x is indeed going to be the one that we've drawn on the picture, the one pointing upwards rather than the one pointing downwards, because if the vector given by this formula here was the one pointing downwards, then that linear transformation would not be orientation preserving. Let me expand that for you. So in this linear transformation, we're taking I onto A, we're taking J onto B, and then we're taking K onto X, where X is given by this formula. If X was pointing downwards, that linear transformation would not be orientation preserving, because as you can see, I is going up here, J is going here, K should be going to something that is then pointing upwards with respect to what I and J are being transformed onto. If it was being transformed onto this thing pointing downwards, that would be a non-orientation preserving linear transformation, and then the determinant of the matrix describing that linear transformation would be negative. And indeed, if you put in the negative of this answer, which is the vector that points downwards, if you put that in here instead of this, and take the determinant, you'll see that the determinant you'll get out would be negative, i.e. it would be a non-orientation preserving linear transformation. So the fact that when you put this in here and take the determinant of that, you get a positive number, that means that the linear transformation is going to be orientation preserving, and because of the way I, J and K are oriented, which obeys the right-hand rule, then what they're being transformed onto must also obey the right-hand rule, i.e. this vector must be pointing upwards on this picture. It must be the correct one, the one that obeys the right-hand rule. So we have now shown how this formula for the cross product gives a vector that is both perpendicular to A and B, how its modulus is going to equal the area of the parallelogram defined by A and B, and how it's going to obey the right-hand rule. Hence, we have explained why this formula for the cross product works. So with that, we will end the video. Thank you for watching.